According to the National Electrical Code, specifically Article 440.12 in the 2020 edition, motor control centers shall be located in ventilated, accessible rooms or enclosures. These rooms or enclosures must facilitate energized maintenance and prevent falling dirt, also providing a minimum of 18 inches clearance to live parts. Air handling units are commonly equipped with multiple motors that are controlled by a motor control center. Consequently, the motor control center serving the air handling units must adhere to the aforementioned NEC requirements. Placing the motor control center inside the mechanical room is permissible contingent upon meeting certain conditions. Firstly, adequate ventilation is paramount. The mechanical room must possess sufficient ventilation to preclude overheating of the motor control center and its constituent components. Secondly, accessibility is crucial. The motor control center must be readily accessible for both maintenance and repair activities, encompassing both the energized and energized states. Ample clearance surrounding the motor control center is mandatory to ensure safe working conditions. Thirdly, prevention of falling dirt is necessary. The mechanical room's cleanliness must be maintained, ensuring it is devoid of falling dirt that could potentially contaminate the motor control center or its internal components. Fourthly, a minimum clearance to live parts must be maintained. A clearance of at least 18 inches to live parts of the motor control center is imperative, even when doors or panels are open. In conclusion, the placement of the motor control center for the air handling units within the mechanical room does not inherently contravene the NEC. However, strict adherence to the conditions outlined is essential to uphold code compliance. Failure to satisfy any of these conditions necessitates relocating the motor control center to a dedicated enclosure or electrical room. Consider the National Electrical Code requirements related to working space about electrical equipment. NEC Section 110.26 dictates specific requirements for working space around electrical equipment operating at 600 volts, nominal, or less to ground. This section mandates sufficient access and working space for safe operation and maintenance of such equipment. The depth of the working space, as detailed in Table 110.26a, hinges on the voltage to ground and the specific condition. Condition 1 stipulates exposed live parts on one side and no grounded parts or grounded parts protected on the other side of the working space. The required depth varies based on the voltage. For instance, equipment operating at 0 to 150 volts requires a minimum depth of 3 feet, while equipment operating at 151 to 600 volts mandates a depth of 3 feet. Condition 2 addresses exposed live parts on one side and grounded parts on the other side. The depth requirements differ. Equipment operating at 0 to 150 volts necessitates a minimum depth of 3 feet, whereas equipment operating at 151 to 600 volts demands a depth of 3.5 feet. Condition 3 involves exposed live parts on both sides of the working space, with operators needing to be in the space when energized. In this scenario, equipment operating at 0 to 150 volts requires a minimum depth of 3 feet, while equipment operating at 151 to 600 volts mandates a depth of 4 feet. The width of the working space, as outlined in NEC Section 110.26 ATWO, must be a minimum of 30 inches or the width of the equipment, whichever is greater. Furthermore, the height of the working space, as specified in NEC Section 110.26 A3, should be at least 6.5 feet or the height of the equipment, whichever is greater. Access to the working space should be provided as per NEC Section 110.26c. Entrances to the working space must be of adequate size and location to permit unobstructed access to the equipment. Moreover, NEC Section 110.26c addresses working space illumination. Adequate illumination must be provided in the working space surrounding electrical equipment. The lighting should be arranged to minimize shadows and ensure safe working conditions. Headroom requirements also play a crucial role in ensuring safe working conditions around electrical equipment. NEC Section 110.26 A3 mandates sufficient headroom in the working space. The minimum headroom clearance should be 6.5 feet or the height of the equipment, whichever is greater. This headroom clearance allows personnel to stand upright and move freely while performing maintenance or repairs on the equipment. Adequate headroom prevents accidental contact with energized parts and reduces the risk of electrical shock. Furthermore, it facilitates the use of tools and equipment without obstruction, promoting efficiency and safety. When assessing the suitability of a mechanical room for housing a motor control center, careful consideration must be given to these working space and headroom requirements outlined in the NEC. Compliance with these requirements ensures that personnel can safely access, operate, and maintain the motor control center without exposure to electrical hazards. Failure to provide adequate working space and headroom can lead to accidents, injuries, and code violations. The NEC also addresses the protection of electrical equipment from physical damage. NEC Section 110.27 covers the guarding of live parts. Live parts of electrical equipment operating at 50 volts or more must be guarded against accidental contact. Guarding can be achieved through various means, such as enclosing the equipment in cabinets, installing barriers, or elevating the equipment above the floor. The choice of guarding method depends on the specific application and the level of protection required. In addition to guarding live parts, the NEC also addresses the protection of electrical equipment from physical damage. NEC Section 110.11 covers the deterioration of equipment. Electrical equipment must be suitable for the environment in which it is installed. Equipment installed in wet, damp, or corrosive environments must be specifically designed and labeled for such use. Additionally, equipment must be protected from physical damage such as impact, abrasion, or exposure to chemicals. Methods of protection include using enclosures, guards, or barriers. Consideration should be given to potential sources of physical damage in the mechanical room. For example, the motor control center should be protected from impact from moving equipment, such as carts or forklifts. It should also be protected from exposure to water or chemicals that may be present in the room. Proper protection of electrical equipment from physical damage helps ensure its continued safe and reliable operation. The NEC provides guidelines for identifying qualified electrical workers. Understanding these guidelines is crucial for ensuring that only competent individuals perform electrical work. NEC Section 110.26F addresses the requirements for qualified persons. A qualified person is defined as someone who has the skills and knowledge related to the construction and operation of electrical equipment and installations and has received safety training to recognize and avoid the hazards involved. Employers are responsible for determining whether their employees are qualified to perform electrical work. This determination should be based on factors such as education, training, experience, and demonstrated competence. Employers should also provide ongoing training to ensure that their employees remain qualified. Qualified persons should be familiar with the NEC and other applicable standards. They should also be able to read and interpret electrical drawings and specifications. Furthermore, they should be proficient in the use of electrical test equipment and tools. Using qualified persons to perform electrical work helps ensure that the work is done safely and correctly. It also reduces the risk of electrical accidents and code violations. The NEC outlines requirements for maintaining electrical equipment in safe working condition. Regular maintenance is essential for ensuring the continued safe and reliable operation of electrical equipment. NEC Section 110.3b covers the examination, installation, and use of equipment. Electrical equipment must be installed and used in accordance with its listing and labeling. Equipment must also be maintained in good working condition. Maintenance should include regular inspections, testing, and cleaning. Inspections should be conducted to identify any signs of damage, wear, or corrosion. Testing should be performed to verify the proper operation of the equipment. Cleaning should be done to remove any dirt, dust, or debris that could interfere with the equipment's performance. Maintenance should be performed by qualified persons. Maintenance personnel should be familiar with the equipment and its operating characteristics. They should also be trained in safe work practices. Proper maintenance helps prevent electrical failures, reduces the risk of electrical accidents, and extends the life of the equipment. The NEC provides requirements for electrical safety training programs. Providing adequate training is crucial for ensuring the safety of electrical workers. NEC Section 110.26F requires that qualified persons be trained to recognize and avoid the hazards involved in working with electrical equipment. Training programs should cover topics such as electrical safety principles, hazard recognition, safe work practices, and the use of personal protective equipment. Training should be provided by qualified instructors. Instructors should have the knowledge and experience necessary to effectively communicate the information. Training should be conducted on a regular basis. Refresher training should be provided to ensure that workers maintain their knowledge and skills. Training should be documented. Records should be kept of the training that each worker has received. Adequate electrical safety training helps prevent electrical accidents and reduces the risk of injuries. It also promotes a culture of safety in the workplace. The NEC includes requirements for arc flash hazard analysis. An arc flash is a dangerous electrical explosion that can occur when a fault in an electrical system creates a high-energy arc. Arc flashes can cause severe burns, injuries, and even death. NEC Section 110.16 requires that electrical equipment be marked to warn qualified persons of potential arc flash hazards. The marking should include the nominal voltage, the arc flash boundary, and the personal protective equipment required to work safely within the arc flash boundary. An arc flash hazard analysis should be performed to determine the potential arc flash hazards associated with electrical equipment. The analysis should consider factors such as the voltage, current, and clearing time of the protective devices. The results of the arc flash hazard analysis should be used to select appropriate personal protective equipment and to develop safe work practices. Performing an arc flash hazard analysis helps protect electrical workers from the dangers of arc flashes. It also promotes compliance with the NEC. The NEC specifies requirements for personal protective equipment for electrical workers. Providing appropriate personal protective equipment is essential for protecting electrical workers from electrical hazards. NEC Section 130.7 specifies the requirements for personal protective equipment. Personal protective equipment should be selected based on the potential hazards to which the worker may be exposed. Common types of personal protective equipment include arc-rated clothing, safety glasses, gloves, and footwear. Arc-rated clothing is designed to protect workers from the thermal effects of arc flashes. Safety glasses are designed to protect workers' eyes from flying debris. Gloves are designed to protect workers' hands from electrical shock and burns. Footwear is designed to protect workers' feet from electrical shock and punctures. Personal protective equipment should be properly maintained and inspected before each use. Damaged or worn equipment should be replaced immediately. Using personal protective equipment helps reduce the risk of electrical injuries and fatalities. It also promotes a culture of safety in the workplace. The NEC addresses requirements for surge protection devices. Surge protection devices are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, utility switching, and other events. Surges can damage sensitive electronic equipment such as computers, televisions, and appliances. NEC Section 230.67 requires that surge protection devices be installed in certain electrical systems. Surge protection devices should be installed at the service entrance and other locations where sensitive equipment is connected. Surge protection devices should be selected based on the voltage and current rating of the electrical system. Surge protection devices should be properly installed and maintained. Using surge protection devices helps protect electrical equipment from voltage surges. It also extends the life of the equipment. The NEC includes requirements for grounding and bonding. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip protective devices and prevent electrical shock. Bonding connects all metal parts of an electrical system together, which helps to equalize the voltage and reduce the risk of electrical shock. NEC Section 250 specifies the requirements for grounding and bonding. Grounding electrodes should be properly installed and connected to the electrical system. Bonding conductors should be sized and installed according to the NEC. Grounding and bonding systems should be regularly inspected and tested. Proper grounding and bonding helps prevent electrical shock and reduces the risk of electrical fires. It also promotes compliance with the NEC. The NEC specifies requirements for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Overloads occur when too much current flows through a circuit, which can cause the wires to overheat and start a fire. Short circuits occur when there is a direct connection between two conductors, which can cause a large surge of current to flow through the circuit. NEC Section 240 specifies the requirements for overcurrent protection. Overcurrent protection devices should be selected based on the ampacity of the circuit conductors. Overcurrent protection devices should be properly installed and maintained. Overcurrent protection devices should be tested regularly to ensure that they are functioning properly. Proper overcurrent protection helps prevent electrical fires and protects electrical equipment from damage. It also promotes compliance with the NEC. In addition to the specific NEC requirements, there are also some general safety considerations that should be taken into account when placing a motor control center in a mechanical room. Firstly, the mechanical room should be kept clean and free of clutter. This will help to prevent accidents and ensure that the motor control center is easily accessible. Secondly, the mechanical room should be properly ventilated. This will help to prevent the motor control center from overheating. Thirdly, the mechanical room should be properly lit. This will help to ensure that workers can see what they are doing and avoid accidents. Fourthly, the mechanical room should be equipped with a fire extinguisher. This will help to put out any fires that may occur. Fifthly, workers should be trained in the proper procedures for working in the mechanical room. This will help to ensure that they are aware of the potential hazards and know how to avoid them. By following these safety considerations, you can help to ensure that the motor control center is placed in a safe and efficient location. The location of the mechanical room itself can also be a factor in determining whether it is suitable for housing a motor control center. For example, if the mechanical room is located in a basement or other area that is prone to flooding, it may not be a suitable location for a motor control center. Similarly, if the mechanical room is located in an area that is subject to extreme temperatures, it may not be a suitable location for a motor control center. In these cases, it may be necessary to place the motor control center in a dedicated enclosure or electrical room. The size of the mechanical room can also be a factor in determining whether it is suitable for housing a motor control center. The mechanical room must be large enough to accommodate the motor control center and all of the associated equipment. It must also be large enough to provide adequate working space around the motor control center. If the mechanical room is too small, it may not be possible to safely and efficiently operate and maintain the motor control center. The design of the mechanical room can also be a factor in determining whether it is suitable for housing a motor control center. The mechanical room should be designed in such a way that it is easy to access and maintain the motor control center. The mechanical room should also be designed to protect the motor control center from the elements and from physical damage. The construction of the mechanical room can also be a factor in determining whether it is suitable for housing a motor control center. The mechanical room should be constructed of fire-resistant materials. The mechanical room should also be constructed to prevent the entry of water and other contaminants. The electrical system in the mechanical room should be properly grounded and bonded. The mechanical room should be equipped with a fire alarm system. The fire alarm system should be connected to a central monitoring station. The mechanical room should be equipped with an emergency lighting system. The emergency lighting system should provide adequate illumination in the event of a power outage. The mechanical room should be equipped with a ventilation system. The ventilation system should provide adequate ventilation to prevent the buildup of heat and humidity. The mechanical room should be equipped with a temperature control system. The temperature control system should maintain a comfortable temperature in the mechanical room. The mechanical room should be equipped with a humidity control system. The humidity control system should maintain a comfortable humidity level in the mechanical room. The mechanical room should be equipped with a security system. The security system should prevent unauthorized access to the mechanical room. The mechanical room should be equipped with a monitoring system. The monitoring system should monitor the temperature, humidity, and other conditions in the mechanical room. The monitoring system should alert personnel if any abnormal conditions are detected. The mechanical room should be inspected regularly. The inspection should be conducted by qualified personnel. The inspection should identify any potential problems with the motor control center or the mechanical room. Any problems that are identified should be corrected promptly. The mechanical room should be maintained in good condition. The maintenance should include cleaning, painting, and repairing any damage. The mechanical room should be kept free of clutter. The mechanical room should be properly lit. The mechanical room should be properly ventilated. The mechanical room should be properly heated and cooled. The mechanical room should be properly secured. The mechanical room should be properly monitored. The mechanical room should be inspected regularly. The mechanical room should be maintained in good condition. The location of the disconnect for the motor control center is also important. The disconnect should be located in a readily accessible location. The disconnect should be clearly labeled. The disconnect should be protected from accidental operation. The disconnect should be rated for the voltage and current of the motor control center. The disconnect should be installed in accordance with the NEC. The disconnect should be inspected regularly. The disconnect should be maintained in good condition. The motor control center should be properly labeled. The label should identify the equipment that is controlled by the motor control center. The label should be legible and durable. The label should be installed in a conspicuous location. The motor control center should be properly grounded. The grounding system should be installed in accordance with the NEC. The grounding system should be inspected regularly. The grounding system should be maintained in good condition. The motor control center should be protected from overcurrent. The overcurrent protection devices should be sized and installed in accordance with the NEC. The overcurrent protection devices should be tested regularly. The overcurrent protection devices should be maintained in good condition. The motor control center should be protected from surge voltage. The surge protection devices should be sized and installed in accordance with the NEC. The surge protection devices should be tested regularly. The surge protection devices should be maintained in good condition. The motor control center should be protected from physical damage. The motor control center should be enclosed in an enumerated enclosure. The enclosure should be properly sealed. The enclosure should be inspected regularly. The enclosure should be maintained in good condition. The motor control center should be installed in accordance with the manufacturer's instructions. The manufacturer's instructions should be followed carefully. The motor control center should be inspected by a qualified electrician. The electrician should verify that the motor control center is properly installed and that it meets all applicable codes and standards. The motor control center should be maintained by a qualified electrician. The electrician should perform regular inspections and maintenance. The electrician should keep records of all inspections and maintenance. The motor control center should be operated in accordance with the manufacturer's instructions. The manufacturer's instructions should be followed carefully. The motor control center should be used only for its intended purpose. The motor control center should not be overloaded. The motor control center should not be operated in a hazardous environment. The motor control center should be kept clean and free of debris. The motor control center should be inspected regularly. The motor control center should be maintained in good condition. By following these safety precautions, you can help to ensure that the motor control center is operated safely and efficiently.